Yes, members of DFS S19, whose class rep is Emily Noma. I think this video is right for you. In our previous classwork, we looked at filtration. Under filtration, actually we looked at the definition of filtration. We looked at some of the various terms that are associated with filtration. The prefilter, that is the slurry that's not been filtered. We looked at the filtrate, that is the liquid that passes through the filter membrane and is collected. We look at the membrane itself, that is the medium that acts to separate the cake and the filtrate. And then we look at the filter itself, that is the equipment in which the filtration takes place. And then we looked at some of the theories that are associated with filtration. We say that actually the filtration exercise actually is induced by various means, and therefore if we just mention some few of them, we have the centrifugal filtration, we have the gravity filtration, we have the pressure filtration and the likes, and even the vacuum filtration. So, and we say that the commonly used filtration operations in food industry include the pressure filtration and the vacuum filtration. Yes. And then we said that during the filtration exercise, there are some resistance that is met by the filtered flow. Yes. This resistance could be offered by the membrane itself. Also, the resistance also could be as a result of the cake. Yes, we looked at some of the factors that actually influence the resistance that is due to the cake. One, we said we looked at the viscosity of the cake. We looked at the area of the cake. We looked at the thickness of the cake. We also looked at the volume of the filtrate delivered, and also the weight of cake that is deposited on the filter membrane. And then after that, we said that actually for us to have a constant rate filtration, that is filtration that is constant throughout, then actually we need to employ some kind of pressure so as to overcome resistance that is offered by the cake and the resistance that is offered by the membrane. And it is inevitable that actually in filtration exercise there is need for pump. Yes. And then after that we came and looked at some of the various types of equipment that are used for the filtration operation. And we said that we can group them into two major categories. That is the pressure filters, and also we can have the vacuum filters. Yes, under pressure filter, we have the plate pressure filter. Yes, and then we have the shell and tube pressure filter. Yes, we have the shell and leaf pressure filter, and the rest. So we looked at the plate and frame pressure filter. That is under plate filtration, we have the plate and frame pressure filter, whereby we say that there are some plates. Yes, and these plates, they are grooved, and then after being grooved, they are covered by the filter membrane. And then on top of that assembly, there will be a frame. This frame will offer surfaces and space onto which the cake accumulate during filtration. Yes, so that when we come and introduce the cake at a pressure, yes, the cake will accumulate in the spaces in the frame, while allowing filtrate to pass through the membrane and then out where the grooves on the plates to the where they're collected might be sumps. Then after that, we said that after that we said that after that we said that actually when we squeeze the assembly together, yes, the membrane will act as a gasket that is preventing the leakage of the filtrate between the grooves and prevent the leakage of the filtrate between the grooves and the frame. Then again, apart from the plate and filter press, we came and look at the recessed plate, which I would call, I told you that you find time to draw the diagram of a recessed plate. So these are plates actually, and the plates, they have some kind of folding ins. They're called recesses, pockets, or whatever, crevices. So that we have the membrane, we have the plates, and then we have the membrane inside these plates. So that when the filtrate is introduced, the filtrate is introduced from the sides, that is the slurry is introduced, yes, it comes into the recesses, and under pressure, the filtrate will get out where recesses, while the cake builds up in the space there. Yes, and then we come and look at we looked at the shell and tube pressure filter, where we say that they have some basic elements. So these elements are some of the objects upon which the membranes or the membrane is stretched. So we call them the elements. So when the element is a tube, and this tube is placed inside a pressure-tight vessel, we can call that one a shell and tube pressure filter. And also, not necessarily must it be a tube. We can also overstretch the membrane on might be a grooved timber. We can stretch them on screens. We can also overstretch them on wire meshes. Yes. Wire meshes, screens, all might be a folded wire. So in such circumstance, we call that one a leaf. And when this leaf is placed inside a pressure-tight vessel, such that filtration takes place there, then we can call that simply as shell and leaf pressure filter. And then eventually, summing up the topic, we looked at the vacuum, that is the vacuum filtration, whereby we said in this case we apply the sub-atmospheric pressure, that is reduced pressure in the downstream, while maintaining atmospheric pressure on the upstream. Yes, and also, yes, yeah. So, and then we drew the diagram of the vacuum pressure filter, that is vacuum filter. And then eventually, when we were wrapping up our lesson, we said that we looked at the application of filtration in the food industry. Are we together? And then from there also we mentioned something like cakes. We see that there are two types of cakes. We have the compressible cake and we have the incompressible cake. And we say to some extent it is very much cumbersome to deal with what? It is very much cumbersome to deal with incompressible, that is compressible cake. Because to some extent they will block the membrane channels, the pores on the membrane. That in that case they impede the filtration process. So what we do is that before we start the filtration exercise, what we do is that we cover the surface of the membrane with some incompressible solids, and we see that these solids are called filter aid. We can even use sand, yes, we can use diatomaceous earth and the rest, yes, as our filter aid. I think that was it all about, and the application how you apply the filter aid. So should it come to whatever question that you need in your exams, please answer them appropriately. Your notes, use your notes, rehearse until it sticks. Then our next topic that we are going to start on is the membrane separation. So we have various separation techniques. For example, we can separate substances on the basis of their boiling points. That one is called, in terms of their boiling point. For example, one substance could be boiling at a low temperature and that one can be boiling at a high temperature. That process of separating substances on the basis of their boiling points is called distillation. Also, we can separate them in terms of sublimation. There is some will change the state directly from one state to the other. Yes, that is also another kind of separation technique. Yes, we can use in food industry. That is what we use. We talk about we can talk about evaporation. That is whereby we are removing water from what? From we are removing water from a solution or from a solution through application of heat. In this case also, we are going to look at how, for example, you can remove water, yes, from a concentrated solution by use of membranes. In this case, we don't apply heat, but we just apply some very low kind of pressure. So, in your high school, you defined osmosis as the movement of water from a region that is lowly concentrated to a region that is highly concentrated. And then also you say that there is this diffusion. Diffusion is now the opposite of osmosis. And you say that diffusion is now the movement of molecules. Movement of molecules from a region that is highly concentrated to a region that is lowly concentrated. And we say that for water movement from a region that is lowly concentrated to a region that is highly concentrated, there could be some kind of setup or membrane in between. So the question is, why is it that this membrane only allows water to move across and not the solvent or the solute? What we're saying that there might be the solute has got sizes that are incapable of passing through the membrane pores, or it could be that there is some kind of force in between water and the solute, and this force is skewed towards the solute, and therefore the water tends to move towards the solute. Those are some of the reasons as to why it would be like that. Yes. So in this aspect, we can work the process of osmosis. That is to make it move from a region of highly concentrated region to a region of low concentration. That is by application of an opposite pressure. So if we apply pressure on one side and then we have the membrane stay intact, what happens is that so long as the membrane is capable of withstanding the applied pressure, and the pressure is not too much concentration to a region of low concentration is called reverse osmosis. Yes. So in that case, we say that it is only water that will move across the membrane. And on the other side, we're going to retain what? We're going to retain the solutes. That could be salt, or it could be salt, sugar solution, or whatever. Could be sugar solution anyway. Let's just say sugar solution. Yes. That is it. And then, to some extent, we say that the solution itself could be a mixture of various solids. It could be a mixture of salt, sugar, or any other solid. So you find that the solids could be varying in sizes. As in, when you look at the salt, that is the sodium chloride, and you look at we compare it with the size of glucose. Yes, even the weight of glucose versus the weight of sodium chloride. Realize that glucose has got bigger size as compared to sodium chloride. And then in that case, if you want to separate and we apply pressure, you realize that, and then we provide a membrane that can allow the movement of salt across. Yes, that is capable of allowing the size of salt to pass through it. Then the salt will pass through the membrane, while sugar will be left on the other side. So in that case, we shall have separated the sugar and the salt, so that the sugar remains on the other side, since it is not capable of passing through the membrane, and the sugar and the salt will on the other side. So the process of separating two or more solutes that vary in their sizes is called ultrafiltration. Yes, ultrafiltration. Ultrafiltration, that is it. And then as I mentioned earlier, that these membranes are the membranes that we use for this kind of separation. They should be having some kind of characteristics. One is that they should be capable of withstanding the pressure that is applied, so that it should not burst while we are in the process of separating. Number two is that you see, we talked about marriage hygiene. Yes, that during cleaning, please, we may use some detergents. We may use detergents, and also we can use steam. So the membrane itself should withstand the kind of detergent that will be used for cleaning. And also, the membrane should withstand all the operations. Could it be cleaning operation? Could it be separation itself? The membrane should withstand. And then the membrane should not react with whatever is being separated whatsoever, so as to impart any off odor or any off color. These membranes, they come in various forms. They can come in form of a sheet. Yes, they can come in form of cylinders and many other shapes anyway. So it depends with what you want to separate, and yes, the equipment actually that we are using in that case. And then we are saying that for us actually to run might be RO UF, that is reverse osmosis UF. We must have a pump. Yes, we must have storage tank. We have to have the membrane modules and the rest. So please ensure that you have those ones before you begin the ultrafiltration or reverse osmosis kind of business. And then let's look at some of the application of the memory separation, that is the UF and RO one, we can use it. We can use the RO or UF as a concentration technique. Yeah, we can use it as a concentration technique, so that actually we have a concentrate obtained by removing water. But in this case, we don't apply heat. We only apply some kind of little pressure. Number two is that we can use the RO or UF to remove salt from water, so that we have this kind of mineral water. And specifically, mineral water is obtained by RO, the UF, because we need to balance the mineral salts that is there in that water. And then we can use it. We can use the RO or UF for recovery of whey and recovery of sugar from confectionery solution, that the wash water that has been used there. So that instead of this sugar going to drains, they can be used, reused, recovered, and then reused. And then I think that is all about the separation. In our next lesson, I think let's start with something else. I'm sending you notes where they was up. I'm sending you some in your e-learning portal. Have them. I felt that actually I felt like capturing this live video, but actually you don't feel missing me so much while I'll be away. So guys, ensure that you visit your portal for the notes. There's some diagram that you'll draw. And then the topic was just a short search. Have a nice time. I'm Mr. Giovanni.